Nice. So up to now, we got the same type of relation and equation. That is very interesting. Now, how to develop the solution? How to develop the solution? Just I'm starting with one equation. D2v dx2 is nothing but del square v. Now we want to solve this problem, right? Solution also, it is quite similar. V of x, we can write v plus e to the power minus gamma x. If you understood today's class also, our physical class, so this is almost similar. Why I'm writing this one? There are two types of voltage. One is traveling in positive x direction. One is traveling in negative x direction. Right? And the solution, what we are getting is in the form of that only. Because so the solution will be, there are two components. Yeah, I think in engineering mathematics you have done this one. D2V, this is a square and all these things. You getting minus and plus. You just check. There are two type of components. So here also we will be getting this one, and I am writing V plus Y because this is traveling in which direction? Minus. Same thing. Today also I told minus x is plus x direction. Correct. So this is positive traveling wave. This is called what? Positive, or we can write traveling wave in positive x direction. This is nothing but again the traveling wave, but in negative x direction, because plus x. Similar concept, what we have discussed so far today. And gamma, we know this is alpha plus j beta. This is also same. The concepts are same. Alpha is your attenuation, this is phase constants, all these things are same. So there are, the voltage itself is constitutes of what? One traveling wave in positive x direction, one traveling wave in negative x direction. And from where we solution we get and all these things, it's out of scope for this class. But in engineering mathematics, you see, I think you know how to solve and all these things. You will be getting two uh, roots, one minus gamma and plus gamma. Okay. I'm not dealing with that one. Now, if I just do voltage in the form of x and t, right? Today also I told, if you remember, phasor form, right? Uh, Phasor form I told, right? E naught, e to the power minus gamma into z, like that. But phasor form, how to get a phasor form to a original vector notation? What I told, yeah, real part should be removed, and e to the power j omega t will be there. Here also same. So it will be what? V of x multiplied with e to the power j omega t. Because this, let's say this is in the form of a phasor. So you have to multiply with e to the power j omega t. So same thing we have to do for positive traveling wave. What we can write? This is nothing but v plus e to the power minus gamma x into e to the power j omega t. You just see over here. V plus e to the power minus gamma x multiplied with e to the power j omega t. Then only your voltage will be space and time dependent. And another component will be there, V minus e to the power plus gamma x e to the power j omega t. Very simple. So what we can write? Can we write V plus e to the power minus, this is alpha x e to the power minus j beta x j omega t, right? Plus V minus, again same thing, minus alpha x multiplied with e to the power minus j beta x. This is all about understanding. No need to memorize all the equations and all. V plus e to the power minus alpha x. Look here, j, I am taking common, huh? Minus j, it will be coming omega t minus beta x. Just I'm checking.
Sir, here V plus and V minus are just direction.
Just V plus and V minus. It represents the traveling wave is traveling in positive x direction. It is traveling in negative x direction. So this is a representation only. Just to represent the traveling wave is traveling in which direction? Minus is there. So positive x direction. Here it is minus x direction. That's why V minus is there. Okay. Plus V minus e to the power minus alpha x e to the power j omega t. It will be minus beta x.
Both are propagating in same direction.
One second. Some mistake I've done. This is minus, na? This is plus, sorry. So this will be plus. Correct. Check. This will be gamma x, alpha plus j beta, correct. So like that, something will be. So this is your real component, real part, and this is your imaginary part. Again, this is your real part, and this is your imaginary part. Now, if alpha is equals to 0, alpha 0 means what I told in the first class, right? I'm just telling you, if you can remember, E naught e to the power minus alpha z cos of omega t minus beta z, whatever may be, ex, same, na? Now, what is the meaning of this one? Meaning is cosinusoidal signal is there, but it is decaying, right? Because alpha is there. Now, if alpha is 0, then what will happen? It is nothing but a cosinusoidal signal. Same. But there is no decay element. Correct. And this is periodic. And what I told minus beta z means it is traveling in plus z direction. That also I proved. Here also same thing is happening. If alpha is equals to 0, so we can get this is v plus e to the power j omega t minus beta x. And here we will be getting v minus e to the power j omega t plus beta x. Now, if you can write the real part of this one, what is the meaning? This is nothing but cos of omega t minus beta x, right? V plus will be there. Similarly, it will be v plus cos of omega t plus beta x. Something will be there. Now you can easily prove what I told at that time. Uniform plane waves is traveling in how to prove, right? It is traveling in plus x direction, plus z direction. I'm not telling. So similarly, you can also prove from here that the traveling wave is traveling actually in plus x direction, minus x direction, like that. Okay. Now another thing, just I want to say, alpha and all these things are there. Alpha unit, this is nothing but Nepad per meter. Remember that one. In the exams also, some questions will come like, let's say V plus is there. V plus means traveling wave. It is traveling in positive x direction. Always you remember like that. After attenuation, let's say it is V plus e to the power minus alpha x. Just I'm telling. And attenuation is in the form of 1 by alpha, right? It is in the form. Now, if I want to write the attenuation in dB, decibels, what to do? 20 log e to the power minus alpha x. And for attenuation, you have to write some minus term will be there. So this is the thing. Now, if x is equals to 1, and alpha is also 1, let's say, then what it will come? 20 log E inverse minus. So it will be coming some 8.68 dB. You can check in the calculator.
Sir, why minus?
This minus represents there is some attenuation. That's why we place some minus. Otherwise, if you don't put this minus, it will be coming minus 8 dB. Look here, this is the idea is same. What I'm telling, this minus why it is coming because of the attenuation only. So minus 8 dB you can write or plus 8 dB, whatever may be. So my intention is what? 1 Naiper per meter is equivalent to 8.68 dB per meter. So this much attenuation is there for 1 Naiper per meter in dB. That I want to say. You cannot put this, you don't have to put this minus also. It is coming here. The minus will come here. What is the meaning? Meaning is what? If alpha is 1, alpha means what? Your attenuation only. It is in Naiper per meter. So 1 Naiper per meter means alpha is 1. So your dB, how much dB per meter it is changing, or how much dB per meter it is attenuating. It is 8.68. So 8.68 dB or decibel, it is attenuating for 1 Naiper per meter. If alpha is 2, it will be what? You can easily check double of that one. Why I'm doing? Because in some problems, they are giving in dB per meter. Understood? Not in Naiper per meter. If the question is coming, alpha is given 1 or 2 Naiper per meter, then you do accordingly. But if it is given in dB, this is the relation between dB and this alpha. You need to change. If it is in the dB, you need to change in Naiper per meter. That is my intention. Okay. So please remember. So 1 Naiper per meter is equivalent to 8.68 dB per meter. Okay. And this calculation is coming like that only. And provided your X is also 1. Otherwise, it will not come. Another problem may come like that. Very simple. Example 1. You do it in your own. Resistance is given 0.5 ohm per meter. Inductance is given 0.2 microhenry per meter. Capacitance is given 100 picofarad per meter. And all these things will be there in per meter only. So you don't need to change. Students may get confused. Okay, it is given in per meter. So I have to, what I will write. So all the units will be per meter only. 0.1 mho per meter. Frequency is given 1 gigahertz, right? It is, can you find gamma? And second question is find alpha and find beta. This is your home task, you do. I am giving one hint. Alpha, gamma is nothing but R plus j omega L. All the parameters are given only. J omega C. And this is nothing but alpha plus j beta. So from there, you have to get a relation between alpha and j beta. Means you place these equations in this form, you make it in the form of x plus jb or x plus jy, so that you will get alpha plus j beta. From there, you can easily get x and y and beta. But it is not so easy. I think it will not come. But I'm giving one home task. So alpha and beta you need to find out. And gamma is very simple. Anyone can do. But alpha beta is tricky. So try that one in your home. Okay. Up to this is clear or not? Tell me. I hope I am not burdening so much, all of you. Very slowly I am dealing. Naveen, any confusion? Nandan and others up to this? Then we will be going for the next one again.
Sir, can you go to slide 9, page 9?
Here, na?
Sir, here you told
Hmm.
real of what, sir? Real of?
Just I am telling. E to the power j is there, so I am telling this is your imaginary part, and this part is your real part. Just I am telling. In the equation, this is your imaginary part and this is your real part. Right. I want to tell like that because j terms will be. Here also same.
And in the next page, you wrote mod of Vx plus what is it? V
Uh,
plus.
Yes, yes. This is nothing but the magnitude part. Magnitude part of V plus. What my intention is, if this is your positive V plus, maybe what is your V plus? This is your maximum voltage of the traveling wave when it is traveling in positive x direction, right? Let's say you just see this diagram. This is traveling in which direction? This is x, na? So it is traveling in positive x direction. It can travel in negative x direction, but this V plus represent this point. This point is your V plus. Now, due to attenuation, it will change, right? Exponentially, it will decay. So we have multiplied this with e to the power minus alpha x. That I need to say.
So that e power minus alpha x is just representing attenuation.
Only attenuation. This term, you will please recall this same thing. E naught is nothing but your V plus. E to the power minus alpha z is nothing but your this. Same thing. Okay. You can relate these two, transmission line and traveling wave, uniform plane wave, all are very beautiful subject. These two are relative. All are same only. You can relate these two. If you understood this thing very beautifully, this is same only. Those who missed the class, okay, anyhow, I'm doing the recording. If I get the chance, again, I will repeat in the physical class. But let's see. I may not get that one. Okay. Look here. Now we will be starting some analysis from here. Once again, where I have written. Go for the first, where I have written dv dx. Okay, okay. One second. Okay. This thing, this equations. Concentrate on this equation. dv dx is nothing but minus r plus j omega L into I. Now, what I told about this V, this V represents a traveling wave in positive x direction. E to the power minus gamma x is there. Let's say phasor form we are taking. We are not dealing with time domain, only space domain we are doing. Another is minus e to the power plus gamma x. Very simple, right? And I is nothing but what? Same I plus e to the power minus gamma x plus I minus e to the power plus gamma x. Correct? Now, just just replace these two equations. d dx. Instead of v, we are writing v plus e to the power minus gamma x plus v minus e to the power plus gamma x minus r plus j omega L. I is nothing but I plus e to the power minus gamma x plus I minus e to the power plus gamma x. Okay. Now do the differentiation. What it will come? It will come v plus e to the power minus gamma x will come minus gamma, right? E to the power minus gamma x. Then this will come plus gamma v minus e to the power gamma x. Correct? Please check, huh? It will come like that. minus r plus j omega L. Just simple derivative we have to. And this is nothing but I plus e to power minus gamma x plus I minus e to power plus gamma x. Okay. Now you compare. This thing is what? Representing a voltage wave traveling in plus x direction. A voltage wave traveling in minus x direction. Here also same thing. Look here. So this is plus x direction. This is minus x direction. This is minus x. This is plus x direction. So can we compare these two? Plus x with plus x, minus x direction with minus x. So can I write like that? Look here, minus gamma v plus e to power minus gamma x. Can I write it is equivalent to minus r plus j omega L? Just we are writing in this form. I plus, correct, e to power minus gamma x. So plus x direction we are comparing with plus x. So these two will cancel. So what it will come? It will come some, this minus will also. Huh? So it will come gamma into V plus is nothing but R plus j omega L into I plus. It is coming like that. Similarly, if you do the analysis for minus x direction, so you do that one. This thing and this thing will be, some minus will be there, right? This minus will be there, remaining all will cancel. So you will be getting gamma into V minus is minus of R plus j omega L into I minus. You please verify. If you compare these two equations, you will be getting minus. Very simple, same type of things, right? So in the next page, again, I'm writing same thing. So what we are getting?
Sir, can you go back?
You check. These two things we have compared, these two things we have compared. We are getting this type of equations. Just now you
Okay.
do V plus with I plus. Very simple things. Again, I'm writing. So what we are getting, gamma into V plus is nothing but R plus j omega L into I plus, correct? So from there we are getting V plus divided by I plus R plus j omega L divided by gamma, correct? Similarly, gamma into V minus R plus j omega L I minus. So you will be getting V minus I minus R plus j omega L by gamma. Now why this minus is coming? Same thing. Because the wave is traveling in minus x direction. When it is a physical interpretation. Why this minus is coming? Okay. Now what is gamma? Can we write V plus by I plus is R plus j omega L. What is gamma? Root over R plus j omega L into G plus j omega C. Already we have, I told that one. So it will be cancelled. It is coming what? R plus j omega L divided by G plus j omega C. Similarly, V minus by I minus, it will be coming what? Minus of same R plus j omega L, G plus j omega C. These two terms are called characteristic, very important, characteristic impedance. These two terms are called characteristic impedance, and it is written by Z0. So characteristic impedance is nothing but the ratio of the traveling wave or traveling voltage in positive x direction with the positive x direction for that of the current. And it is nothing but negative of that the traveling wave traveling in the negative x direction to that of the negative x direction for the current. So that's why it is coming minus. So very important relation. Okay. And it governs the energy flow of transmission line. Where the energy flow will be there and how much energy flow will be there for the transmission line, this characteristic impedance will govern. I think all of you have understood. Again, another
Sir, can
topic.
you repeat the last statement?
Okay. Last statement, what I told, V plus by I plus. This is nothing but your characteristic impedance. It is nothing but R plus j omega L divided by G plus j omega C. Correct? Now, what I told, it is the ratio of the traveling voltage in plus x direction with that of the traveling current in plus x direction, plus and plus. And it is nothing but negative ratio of what? Traveling voltage in minus x direction with that of the traveling current in minus x direction. And it governs the energy flow. Energy flow. It governs the energy flow for the transmission line. Okay. So I think it is clear. I'm not bothering so much. Up to look here. In this way, we have completed some major portions. I don't think that it is too much complicated for all of you. Then I'm continuing. Another part is there. For today's lecture, another part is there. I think it is clear. Okay. So V plus, I plus, V minus, I minus. I think you know. V plus is what? Voltage wave in forward direction. Okay, I'm writing again. Anyhow, in the notes it is there. Voltage wave in forward direction. Same thing. I plus is what? Current wave. All are wave only. Forward direction. V minus is what? Voltage wave in backward direction. Okay. And I minus is current wave in backward direction. Okay. I think it is clear. And V is nothing but V plus e to power minus gamma x plus V minus e to power gamma x. Please remember this. Already I told these two equations. I plus e to power minus gamma x plus I minus e to power plus gamma x. Okay. Another thing we can I write? Look here. We know Z naught is what? V plus by I plus. Or we can write minus V minus by I minus. Already we proved, na? So can I write this is nothing but V plus by Z naught e to power minus K. And this is nothing but minus of V minus by Z naught e to power gamma x. This also we can write, correct, na? From there. That's very simple. Now why I'm writing? Now look here. We want to solve this equation. We want to solve these equations, but how many parameters are there? Initially, there are V plus, V minus, I plus, and I minus. But we have reduced 4 arbitrary constants to 2 only. Again, V plus is there, V minus is there. So 4 arbitrary constants we are changing to 2. Okay.